Today we're going to start talking about integrals, primarily Riemann sums, and I will show you a couple of examples of that. Let's define the Riemann sum. An integral, a definite integral, is actually an area under a curve. And if I want to take the integral, definite integral, or f of t, from a to b and calculate that area, I can just divide it into a bunch of strips and calculate the area of each strip. For example, area of this strip will be the width of the strip, which is delta x, and the height of the strip, which is f of xi star. And I add those up, and then I make my strips smaller and smaller, and this is called the Riemann sum. Okay? So, and actually when I make my strips infinitely many, I will go and hit the exact area under the curve, which happens to be the definite integral f of t from a to b. Now let's look at a right-hand Riemann sum. Let's say I'd like to calculate the area under this curve, which is x squared, from 0 to 1, this peach color area here. Now, we are going to use 4 strips because if you do more strips, it is the same thing. We are doing the right-hand approximation. In other words, I'm going to make my rectangles so that it will hit f of the right-hand point for each strip. Right here, right here, right here, and right here. So the strips are going to go from 0 to 1/4, and 1/4 to 1/2, 1/2 to 3/4, and so forth. And we go and calculate the area of each rectangle. If you want to do that, you're going to have the width, which is 1/4, and you're going to calculate it with the height, which is the f of that 1/4. Okay? And that's going to be, since f is defined as x squared, you just put square in here. Again, the width and the height, that the x is 1/2, so it's going to be 1/2 squared. So when you add this up, you're going to get this number. Now let's go and try to do this in our graphic calculator. Now let's look at the function itself. So it is y equals x squared. I entered that with this button here. You put x and then squared, and here we go. And you can go and adjust the window, which is going to go from like -1, and you take the -1 here to 5, and then -1 to 25, and you can graph it, and you'll see this graph right here. Let's say I would like to go and enter the x coordinates. You go to Stat Edit, and you enter 0.25, 0.5, 0.75, and 1. Alright? And remember what the L2 is going to be. It's going to be the f of these values. So how am I going to do that? I will go to L2 up, push return, and that's going to be f of this, which happens to be x squared. So I'm going to go and put L1 and square it. When you push enter, look what happens. It just fills up all that. Now, remember how it was? I'm supposed to go and, let me go back to the previous slide. I'm supposed to add these up. And here, as you see, I can just factor out 1/4 and add the squares. So I can do this here. So to add the squares, what I can do, let me go back. I can use something called Stat Calculator. It's a statistics feature. What it does is, when you enter something in a table, it goes and adds them up. It actually does a bunch of statistical things, but right now I want to just add them. So I can do one variable statistics. I want to do one variable statistics on what? Remember, I put all that stuff in L2, so I have to specify that. Second 2 will give me L2, and push enter. Now look, it gives me a bunch of things, but the one that I'm interested in, I want the sum of that column. And actually, it can even do the sum of squares, but just let's look at the sum of that column. And that happens to be 1.875. And you can take 1.875 and multiply by 1/4 to get the sum. So that's a very, very handy tool. and we actually calculated the Riemann sum, the sum of 4 strips using the right-hand points. This time we are going to look at left-hand Riemann sums of the same function, y equals x squared from 0 to 1 with 4 strips, but this time we are going to take the left-hand limits. Now, when I do the left-hand approximation, what you do is you look at the left-hand value of the function. In this case, it's at 0, and then it's at 1/4, and then it's at 1/2, and it's at 3/4. So the strips are the same width, but the heights are different. Okay, so how am I going to go and calculate that? I just draw my y equals x squared, and we are going to go and calculate those left-hand sums. So let me go back, and I will do that with this one, and I'll just enter it, and I'll do it in my calculator. Now what we're going to do, we are going to enter the x's. In this case, it's going to be 0, 1/4, 1/2, and 3/4. So I enter 0, 1/4, 1/2, and 3/4. And remember what it is. It is supposed to be x squared. That's the height. So I will go and I will push enter and take L1 squared, which is second one, and square it and push enter. Here we go. Now remember what I'm supposed to be doing. I'm supposed to be going and calculate this times that, and there's no height, so this one is 0. This times the height, this times the height, this times the height. In other words, if I sum these up and multiply the sum by 1/4, I'm home free. So let's try that. To calculate the sum, I do it the same way, stat, and I'll go to calculate, one variable statistics, and it's going to be on L2. Remember, I put it in L2, and push enter. Here's my sum. It is going to be 0.875. So I can go and say, okay, 0.875, that's my sum, times 1/4, which is 0.25, and that will give me the area, 0.21875. That is the area that I am looking for. So I did the same kind of approximation, but this time I took the right-hand limits. So I got 0.21875 as my sum, or the sum of the areas.